For number 10, to find our x value here, I'm going to have to set up proportions or ratios. So if I look at MO, that's the same as PQ, or sorry, PR. So I would say 4 plus x over 5. And then if I look at MN, which is x minus 2, and MN goes with PQ, that's over 2. And then I could cross multiply and solve. So 2 times 4 plus x and 5 times x minus 2. Here, if I'm going to go like kind of backwards, I'm going to subtract the 2 here, which is 3x. And then if I add the 10 over, that's 18. So x is 6. Okay. In the second problem, again, we need to find corresponding sides. So it looks like we have BE right here, x plus 4. And BE goes with FE. So BE goes with FE. So x plus 4 over 3x plus 1. And then we would have 28 over, so 28 is CE, so GE, 56. Okay, now we also know that 28 and 56 can be reduced. So I know that 7 can go into both of those. So 7 goes in there 4 times. 7 goes in there 8 times. But then that can reduce to 1/2. So I'm going to take 2 times x plus 4 and 1 times 3x plus 4. Okay, if I distribute that, we get 2x plus 8 and 3x plus 1. Okay, so I'm going to subtract the 2x and get 1x, and subtract 1 and get 7. So x is 7. Okay, for the back, it says decide if the triangles are similar. If so, state the theorem that they're similar by. So angle, angle, side, 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 or side, angle, side. That would show that they are similar, and write a similarity statement. If they are not similar, just write no. Alright, so now we need to match up our angle measurements. And so because we're given 2 angles, we need to find the third angle. So if I add up 48 and 55, I get 77 degrees. And I can stop here because I see that 77 match up and 48 match up. Since I have 2 angles that match up, the third angle has to, and we can prove this by similarity angle, angle. Then, for the statement, we would say, okay, triangle GFH is similar to triangle XYZ. So right here it gives you your 2 triangle names. You're just going to write the similarity symbol in between them. Alright, next, in number 13, we're given a side, an angle, and a side. Okay, the angle's in between the 2 sides. So that's so far side, angle, side. We now have to prove if the sides are proportional. So 6 over 9, does that equal 8 over 12? If we reduce the first one, we get 2/3. If we reduce the second one by 4, we also get 2/3. So yes, our 2 sides are proportional, our angles are congruent, and so this is side, angle, side. And again, we're going to use the triangle names right here. Okay, in number 14, it looks like we have 3 sides to compare. So either we're going to prove this by side, 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 or nothing at all. So setting up our proportions, we would have 6 over 9, 8 over 12, and 10 over 15. Now, ironically enough, we just reduced these 2 fractions right here and got 2/3. 10/15 does reduce by what, 5? So 5 goes in 2 and 3. So yeah, it is proven by side, side, side similarity. And then again, I'm just going to recopy these triangles with a similarity symbol. In number 15, we have side, angle, side. So 6/10, 8 over 8. And that is not similar because 1 over 1 does not equal, what, 2, 3, 10 divided by 2 is 5. Does not equal 1 over 1. So no, not similar. And in number 16, we know that this has to be 34 because these are vertical angles. But if you actually add these together and subtract from 180, it gives you that this is 33. And that can't be because that's 34. So if that was 34, you'd be more than 180 degrees. So no, that one does not work either.